In this video we're going to be making some flexible LED panels for video or photography work. Now, not only are these things, well, incredibly bright, but they're also super practical thanks to their ability to be folded into pretty much any shape you want. They're also dual colour temperature, and what this means is that you can fade between warm and cool white for different lighting effects. They're also super light as well. They weigh in at 200 grams, which is about half a pound, and that allows them to be mounted pretty much anywhere. And the best part? Well, they can be built for around £40, which is roughly $60, which is incredible value, especially when you consider how bright they do go and how good the colour rendition is. More on that in a bit though. This is something that's been highly requested by you guys, so sit back and enjoy. So the first thing we'll need for this build are some LED strips. These have surged in popularity in recent years and are available from places like Amazon and eBay for very little money. However, one huge consideration when buying these strips is the quality of their light output, which is a very important factor when it comes to video work. You see, cheaper strips tend to have very low CRI values, meaning that colours can be very muted and sometimes suffer from horrible colour casts. Finding quality strips for not much money is a big challenge, and I went through dozens of strips from different suppliers before I found a set that were good enough for this build. Despite their low cost, the way they render colours is fantastic, certainly good enough for most uses, as I will demonstrate later. So that you guys won't have to hunt around, I've placed international purchasing links to these good quality strips in the description. Though as they ship directly from a factory outlet store in China, you may want to order them straight away so that you aren't left waiting for them to arrive when you want to start this project. Now, as we're making a dual colour temperature panel, we need to get two different colour temperatures to fade between. There are three variations to choose from, so make your choice based on your needs. I'm going to go with the pure white version and the neutral white version. This is because when they're both at maximum brightness, the colour balance ends up being very similar to daylight, which is a fantastic midpoint to have. Some of you will want the panel to extend more towards tungsten, however, so feel free to use pure white and warm white if that's what's required by your needs. A single 5 metre roll in each colour temperature is enough to make a roughly 30 cm square panel, which is what we're going to be making first, as it's a great size to start with. So the first thing to do is cut each strip into 30 cm lengths, making sure to always cut through the exposed copper pads. As you cut through the two rolls, make sure that you keep each colour temperature separate so that you end up with two piles, each consisting of 16 strips. These colour temperature sets will be wired up separately later so that they can be dimmed independently, giving us the ability to fade between them. With that done, it's now time to work on the backing of the panel. What we'll need for this is some false leather. While there's nothing stopping you from using other materials, false leather is a good option because it doesn't fray and is easy to work with. So we'll first mark and cut out a 38 cm square, and then place it backside up on a flat surface ready for us to begin sticking the strips to. The strips themselves have a sticky adhesive on the back, a bit like tape. The problem is that it doesn't stick very well to this kind of surface, so it needs some extra help. What we'll need is some flexible glue that will adhere to both the fabric and the back of the strips, which can just be squashed down on top. This first strip needs to be positioned equidistant from each side, and about 3 cm up from the bottom. Now we need to repeat the process, but this time with a strip of the other colour temperature. When you do this, make sure that each strip is put the right way up by observing the writing on it. This needs to be repeated over and over until all of the strips have been stuck down in an alternating colour temperature pattern. As you go, it's likely that some strips will start peeling back as the glue isn't particularly fast drying. To combat this, we'll squash it underneath something flat and then leave it to dry, which can take several hours depending on the glue. I left mine overnight just to be sure. Once dried, the strip should be very secure, and as you can see, it's so flexible that you can even roll it up. Now it's time to add the wiring. We'll need two sets of wires for this, one black and one red. As we're going to start by wiring up the negative connection, we'll get a bit of the black wire and strip a fair bit of insulation off from one end. We can then move up the wire about 2.5 centimeters and pull that section of the insulation towards the end of the wire like so. This needs to be repeated until there are 9 total exposed sections on the wire. Now we need to fold the wire at each of these points, after which it's ready to solder to the LEDs. We'll start at the bottom of the panel. As you can see, each strip has the positive and negative pads clearly marked, so we can solder our black wire to the pads marked as negative. As we have 2 alternating rows of colour temperatures, however, we need to skip every other row so that we only wire up 1 colour temperature set. We need to then get a red wire and do the same again, soldering it to the positive pads instead. As you can see, the last sections of the wires need to be left loose. The whole process needs to then be repeated, only this time starting from the other side, so that the wires meet in the middle. Now you might suppose that we're going to connect these wires up in parallel, but nope. Instead, what we're actually going to do is wire them up in series. This means that the voltage supplied to each strip is halved, and there are several very good reasons for doing this, which I'll go into further detail about later. So we'll trim down one of the black wires and then solder the red wire from the opposite side to it. This leaves us with a red and black wire which we'll later use to power the strips. Now what we need is some twinned wire, with each wire containing 2 cores. Each of the cores needs to be reasonably thick so that they can carry the power effectively. One of these pairs can then be soldered to the red and black wires, taking note of the polarity and using some heat shrink or electrical tape to insulate the joints afterwards. Now that we have 1 colour temperature set wired up, we can move over to the opposite side and wire up the other colour temperature set in the same manner. Here I used a white wire for the positive connection just to differentiate it. Now we can take a knife and score a little slot in the bottom of the panel for the wire to be threaded through, after which we can use a sharp point to make some holes on either side of the wire and use a cable tie to clamp the wire to the false leather, leaving enough length on the other side for the wires to run along the perimeter of the panel. Now later on we'll be folding over the material to neaten up the edges and to protect the wiring, but before we do that we'll just mark along the fold paths until they intersect. Now what we can do is mark the point 3 centimeters along from the intersection on each side, and then use a knife to cut a slot along this length, giving us an inner corner. Now what we need to do is cut 2 5x5 centimeter squares out of some spare false leather, and then cut them in half diagonally, giving us 4 right-angled triangles. On each triangle we now need to make a mark that's 2 centimeters away from its hypotenuse, and then make a parallel cut down its length. After doing this to all 4 triangles, we can slot them underneath the inner corners we made earlier and add some super glue along the outside edges. We'll follow this up with some fabric glue and then fold the tabs over. The super glue works as a quick grab to keep the tabs held down until the slower drying fabric glue cures. After you've done this 4 times, you'll have some little corner pockets which we'll later use to mount the panel onto an arm. Now as the panel at this point is still super floppy, we need to give it some rigidity so that it can support itself. To do this we'll need some steel wire, usually found in the gardening section of most hardware shops. This wire needs to be bent around the perimeter of our strips and then joined together where they meet with some super glue. This glue is just to hold it in place to make the next steps easier, rather than for structural integrity. So after putting some masking tape down over the strips, we now need to add generous amounts of glue around the edges. Silicone types are great for this so long as they dry flexible, but make sure that it isn't an acid cure variety, as that will likely corrode the metal. We don't need to go right up to the corners at this point, as they'll be sorted out separately later. So now what we need to do is fold over the material and use something like a ruler to push the material's edge downwards whilst the glue dries. The masking tape can then be peeled off and any excess glue carefully trimmed with a knife. When you do this, be careful not to cut into the strips underneath. After this has been done for all the sides, we need to work on the corners. We'll start by cutting through the loop and then trimming them diagonally so that they meet neatly at a 45-degree angle. We can then glue them down, using some masking tape if necessary to help hold them in place whilst they dry. Once each corner has been done, the panel should look something like this. Thanks to the steel wire we just added, it can now be bent into different shapes, and it should now be strong enough to support itself. Now the next thing to sort out is the dimming controls. What we'll need for this are two specific dimmers, links to which you can find in the description. These dimmers work by pulse width modulation, which is usually something you should avoid when it comes to lighting for video work. However, they operate at such an insanely fast rate, 10 kHz to be exact, that any problems with flicker during video recording are completely eliminated at shutter speeds below about 1/1000th of a second, so it's perfectly adequate for this use case. So what we need to do first is get a piece of spare false leather and poke some holes in it for the dimmer's potentiometers to fit through. Before pushing through the shafts, we'll of course have to pull off the knobs and unscrew the nuts. On one side we can now make two more holes for the panel's power wires to fit through, after which each individual pair of wires can be soldered to the outputs of the dimmers, being careful of the polarity, which is thankfully marked on the bottom. Once both wires have been soldered in place, we need to bridge the DC input contacts with some wire so that they're both joined in parallel like so. With that done, we now need to get a length of cable containing two wires like an old mains cable. We need to then make two more holes on the other side of the dimmer unit, through which we can thread this cable and solder it to the DC input of the nearest dimmer. Now we can add some glue to the bottom of both dimmers and stick on a piece of thin board to join them together. After this has dried, the false leather can then be drawn tightly around the dimmers and then glued in place with some super glue. After cutting down each corner, the sides too can be tightly glued in place. Now the nuts can be tightened back up and the knobs pushed back on. This gives us a nice little dimming unit that's light and very compact. The last thing we need to do is get a power socket that's the right size for the power supply you'll be using. More on that in a sec. It can then be soldered to the other end of the DC input cable, using some heat shrink to make it nice and neat. Now the panel is ready to be powered up, for which we'll need a 19-volt power adapter. Now you might be thinking, hold on, the LED strips are rated for 12 volts. Won't powering them with 19 volts fry them? Well, no, because as you remember, we wired the LEDs into two groups of 8, which we then connected in series. This means that with a 19-volt power supply, each strip receives only 9.5 volts. There are some very good reasons for doing this, the first of which is to improve the panel's longevity. You see, the strips themselves, when powered with 12 volts, actually get quite hot. This isn't too much of a problem if they were mounted to a metallic surface, as it would help to dissipate the heat. However, we've mounted them to fabric, and there's really nowhere for the heat to go. So powering them with 9.5 volts is much more sensible, as it means that they now only get vaguely warm, allowing the panel itself to be left on indefinitely without any worry about the LEDs overheating and having a reduced lifespan. The second reason for undervolting them is that it makes powering them so much easier. 19-volt power adapters are very commonplace thanks to their use with laptops. You may very well have an old power adapter just lying around, which you can reuse with this project, thus keeping the overall costs down, which was one of the main priorities with this build. All you've got to do is make sure that it can supply 3 amps or more, and you're good to go. So the only thing left to do now is make a mount to which we can attach an arm, allowing us to clamp the light to pretty much anything we want. To do this, we'll need 2 thin sheets of aluminium, each being 3 cm wide and 50 cm long. As they're so thin, it's pretty easy to trim these off a larger piece by simply scoring it first with a knife, and then bending it repeatedly until it separates. The corners can then be trimmed down to make a 90-degree point at each end. While I didn't do this to mine initially, I do recommend that you use a file to round off these edges afterwards for safety reasons. Now we can clamp them down on top of each other and drill a hole through them at the very centre. For a clean and accurate cut, it's worth starting with a small drill bit, progressively moving to a larger one until it's 6.5mm wide. A knife can then be used to tidy it up. The next thing we'll need is the arm itself, which features a clamp at one end. This thing can be adjusted into pretty much any position, and when tightened is very rigid. Again, I've placed international purchasing links to a good low-cost one in the description. All we need to do now is unscrew the pad from one end, push the bolt through the hole in our aluminium strips, and then screw the pad back on with the rubber bit facing the aluminium. The corners of the strips can then be inserted into the corner pockets on the panel, and with that the whole thing is completed. So how well do they perform? Well, colour rendering wise they do an excellent job, and I measured a CRI of 85 with my spectrophotometer, which isn't bad at all considering the cost of the strips. Here for example I have the LED panel mounted off to my left, and as you can see skin tones look lovely and natural. In fact, compared to my previous panel that I built with lower CRI strips, it positively shines. Now speaking of shining, they're also very bright despite the strips being undervolted. This is thanks to the LEDs themselves being really efficient, so watt for watt produce a lot of light. For example, here's a comparison of the brightness with my old panel. As you can see, they are roughly equivalent, but the main difference is that the old panel uses twice as much electricity to produce the same amount of light as the new one. Crazy! I personally really love how lightweight these are as well, as it allows you to put them pretty much anywhere, and if you knock one over it's unlikely to damage anything. Now don't assume they're just for video work either. Since making a few, I've used them regularly for general illumination as the light they give off is so pleasant. They also make for excellent work lights too, particularly because of their versatility when it comes to mounting options. So overall, a very solid design that's not only practical, but also performs well. By the way, if the 30cm square version isn't bright enough for you, it's very easy to double the brightness by using twice as many LED strips, giving you a panel with twice the surface area. The only differences in the build process are that you need 2 rolls of LEDs in each colour temperature, so 4 in total, which need to be cut into 45cm lengths. These can then be stuck down to a 51cm square cutout. When I was making this one, I tried a different glue method by spreading it around the area first. It's a little quicker doing it this way, but make sure that the glue doesn't start to dry by the time you put on the last few strips. The wires too need to be longer and feature 12 exposed sections instead of just 9. Also, the power adapter has to be able to deliver at least 6 amps instead of 3. The brightness of this bigger panel is incredible, so if you need some seriously bright panels, I do give them a hearty recommendation. Though for most of us, the 30cm square version is more than adequate. So I hope you've enjoyed this video. If you have, don't forget to hit that like button and maybe consider subscribing as well, because that way you'll be notified next time I upload my next how-to video. I'm Matt and thank you very much for watching.